Problem number 8. Tangent theta is 3 root 5 over 2. Theta's in quadrant 1. I want to find the exact value of each of these things. Letter A means square the tangent ratio, right? I can write it out the long way if that's helpful. Square that 3 root 5 over 2. Well, let's do that. 3 times 3 would be 9. Root 5 times root 5 would be 5. So 9 times 5 would be 45 up top. And 2 times 2 would be 4 on the bottom, 45 fourths. Letter B, 5 minus 4 times, now be careful here, it's that whole tangent ratio being squared. So that 3 root 5 over 2 all being squared again. Of course, we just worked that out. We know what that's equal to. It's 45 fourths. So I'll just fill that in. Then the 4's cancel out. And so I'm left here with just 5 take away 45, which is equal to negative 40. How do I switch to a new trig function here in letter C? Probably a picture would be the fastest way to do that. I know I'm in the first quadrant. I can draw my triangle. I know my opposite and my adjacent. Tangent is opposite over adjacent. Let's use the Pythagorean theorem real quickly here. 2 squared plus 3 root 5 squared equals c squared. We've seen these numbers before. This is the 4 and this is the 45. I get c squared equals 49, which of course means that c is equal to 7. And now that I have the hypotenuse, I can fill in the sine ratio. It is just the opposite, the 3 root 5, over the hypotenuse, the 7. This makes part D pretty simple. I just need to fill in the 3 root 5 over 7 when I get to sine theta. I'll be squaring that entire sine theta ratio. Let's see, what will I get? 3 root 5 times 3 root 5, there's that 45 again. And 7 times 7 is 49. I have some canceling that happens. This 7 divides here, leaving me with 7. So I now have 1 take away 45 sevenths. I guess I'll have to think of that one as 7 sevenths minus my 45 sevenths for a final answer of negative 38 sevenths. And then letter E, back to tangent theta. So I have this fraction. On the top is the tangent theta ratio, 3 root 5 over 2. On the bottom is tangent squared theta. Well, we worked that out in part A. I can just fill that in. That was 45 fourths. And then I have minus 9. This is a complex fraction. I think I'll simplify it by finding the LCD of all the little fractions and then multiplying the big numerator and denominator by that number. The little denominators are 2 and 4. The LCD would be 4. 4 is the smallest number they both go into. So I'm going to come here and multiply this by a 4. And I'm going to come down here and multiply this whole thing by a 4. When I do that, all the little fractions will disappear. So on the top, 2 goes into 4 twice, meaning I now have 6 root 5 up there. On the bottom, I'm going to have to distribute. First, the 4's cancel, leaving me with 45. And then 4 times 9 there, the second multiplication would be 36. 45 minus 36 is 9. And the last thing I can do is reduce that fraction. The 5 is trapped, but I do have a common factor of 3 that I can divide out. And so my final simplified answer is 2 square root of 5 over 3. Problem number 9. All I want to say is whether these answers would be positive or negative. Well, it all comes down to the quadrant. So when I see pi over 9, I'm thinking that's a very small angle. I mean, that's smaller than pi over 4, pi over 6. I could put the mental 180 degrees in there for pi. 9 goes into 180 20 times. So this would just be a 20-degree angle. Clearly, I'd be in the first quadrant. And we know that sine is positive in the first quadrant. Letter B, how about 10 pi over 11? Where is that? I mean, obviously I could do the mental 180 thing, but what I'm thinking is 11 pi over 11 would simplify to just pi, to 180 degrees. So 10 pi over 11 must just be a little bit short of that. I'm confident enough to say this has got to be a second quadrant angle. The only function of the big three that's positive in the second quadrant is sine, so tangent then in the second quadrant is negative. And then how about negative 7 pi over 15? 7 is just a little bit short of halfway to 15. If I had 7 pi over 14, it would be exactly negative pi over 2. But 7 pi over 15 is going to fall a little bit short of that. I would need 7.5 out of 15 to get exactly halfway. So it's going to be a little bit short of the negative pi over 2, which means I'll remain here in the fourth quadrant. Cosine, all students take calculus, cosine is positive in the fourth quadrant. Problem 10, let's practice some simplifying. The first thing I notice is that inside the square root in part A, I have a complex fraction. So I will find the LCD of the little fractions. It would just be that 3. And I would multiply this top by 3 and this bottom by 3. When I do that, I won't have any more little fractions. On the top, I have to distribute. 1 times 3 is 3. And in the second multiplication, the 3's cancel, leaving me with 2. The bottom gives me a 9 here. And then this works out very nicely because the top is going to be a 5. So I have square root of 5 on the top. The bottom is just square root of 9, which has a nice answer of 3. And so I'm finished. In letter B, I also see a complex fraction. The LCD of the little fractions would be 6. 2 and 3 both go into 6. So I'll multiply the top by 6 and the bottom by 6. I'll have to distribute on the bottom. What will I get? On the top, 2 goes into 6 3 times, so 3 root 3. On the bottom, 1 times 6 is 6. And then in the second multiplication, 3 goes into 6 twice, times 2 would be 4. If you feel like it would be helpful for you to physically do the canceling out, then just write down the multiply by 6 next to each item. Then you can cross out the factors as you go. Finishing this off, I have 3 root 3 on the top, and 6 minus 4 is 2 on the bottom. Letter C, the LCD of the little fractions would be 2. So I'll multiply this by 2, and I'll multiply this by 2. Distributing on the top would give me 2 root 2 for the first multiplication, and then 11 for the second multiplication. On the bottom, the 2's cancel, and so I just have square root of 2. I am going to have to go ahead and rationalize that, so I'll have to multiply the entire top by root 2, as well as the bottom by root 2. Another distributing then on the top. 2 root 2 times root 2. Root 2 times root 2 is 2, times that other 2 would be 4. I will then have 11 root 2 for the second multiplication. And on the bottom, root 2 times root 2 is 2. Can I go further? Not in this case. Since 4, 11, and 2 don't all share a common factor, there's no more reducing that I can carry out. And so this would be the final simplified answer. And then letter D looks like letter A. The only little denominator is a 5. So I'll multiply here by 5, and I'll multiply here by 5. On the top, I will have to distribute. Let's see, 4 times 5 is 20, and then the 5's would cancel in the second multiplication, leaving me with just 2. On the bottom, I'm going to have 6 times 5, which is 30. So that gives me the square root of 18 over 30. Now those two numbers share a common factor of 6. So I can simplify that to square root of 3/5. In other words, square root of 3 over square root of 5. And then I'll need to rationalize the denominator, and that gives me a final answer of square root of 15 on the top and 5 on the bottom.